Hi friends, this is Ashok Raj. Today I am going to discuss about parallel redundant UPS configuration. So in my last video we have discussed about the isolated redundant configuration. I just recalling that the configurations. In isolated redundant configuration there will be two UPS. One UPS generally is that is primary UPS is supplying the power supply to your critical load, where there was any fault occurs between that rectifier and filter section, the load on that particular section, it automatically transfers to the static bypass of the that primary UPS. In that primary in the static bypass is getting the power supply from the another UPS, that is called catcher UPS. That's what isolated redundant configuration. So if you are not seeing that video, so please go through that video. I have that link of that video I have given in this video description. Okay, that video is available in Tamil, English as well as in Hindi. So please make use of it as per your convenient language. And in this video, I am going to discuss about parallel redundant UPS configuration. So in the parallel redundant UPS configuration, here also there will be a two UPS, or otherwise there will be a three UPS, or there will be a 4, 5, anything. But the parallel redundant configuration can be differentiated as n plus 1 and n plus n. It is based on your load demand. Okay, so in the parallel redundant configuration, so there will be a assume that there will be a two UPS, and generally both the UPS can be connected in different source or can be connected in the same source input. I am talking about input. So for the output part, the output of the both the UPS should be connected in the same bus, that is called parallel system. Okay, that is called parallel system. And another thing is what, if assume that if your load is 60% of you have 60% of critical load. So if you are putting the your load to in the parallel UPS configuration, and the UPS will take one UPS 1 and UPS 2 will be there, and one UPS will take 30% load, another UPS will take 30% load out of your total load. So if any fault occurs between any one of the UPS, the other healthy UPS will take the entire load. That type of capacity should be selected before putting into your UPS configuration, right? So second thing is what, see, this is the single line diagram of the UPS, and C is use nothing but utility, and G is nothing but generator. So CB is nothing but, already you know, it is a circuit breaker. So here see, I am giving the power supply to the UPS 1 and UPS 2 from the same utility source, and the output of these UPS are connected in the common single output bus, and then there will be another one circuit breaker. So and your total the power is going to the critical load. Okay, so already I told. So if generally the load, if your load total critical load is 60%, generally it will take 30 and it will take 30, and if any fault occurs, the entire load will transfer to the healthy UPS. Okay, and here there will be a static bypass switch available. However, in the parallel redundant configuration, the people generally will do that the static bypass switch will be in disabled condition. Why? Because the static bypass switch is giving the raw power. If any fault occurs in this section, the load is automatically go to the static bypass, and there will be a that will not be a good for your equipment. So in this parallel redundant configuration, people generally will disable the static bypass switch. It means that it is available, but it will not. If any fault occurs in this section, generally the UPS load will be transferred to the another UPS. It will not transfer the load to the static bypass. Okay. If you want to configure the two UPS in parallel configuration, there will be three conditions. One is you have to give the output power supply. You have to connect both the UPS in common output bus bar. And second, both the UPS should be in the same manufacturer. It should not be a different manufacturer. If it is a different manufacturer, it cannot be connected in the parallel configuration. And both the UPS should be same capacities. Like if one UPS having 100 kV, another UPS having 200 kV, that cannot be connected in parallel at any time anymore. Okay, so that's why you have to select both the UPS, and both the UPS should be in the same capacity. These are the three conditions. Okay, so this is what parallel redundancy UPS. And already I have explained about isolated redundant UPS. Now I am telling about parallel redundant UPS. People will definitely get the confusion, what type of UPS configuration is best. Like everybody will get that confusion. So that's why I just made I'm giving some score to this configuration based on 5 criteria. So it's nothing but one is nothing but the reliability. So in the reliability, I gave a score as 4. Why? Because in this UPS configuration, the load sharing between the UPS is happening, right? So that is one of the advantage, and another advantage is nothing but the fault clearing capacity is high in this UPS configuration. Okay, so that's why I made as I gave a score as 5. So I gave a score as 4 out of 5. Okay, for reliability. So and the next one is complexity. In complexity, I made as 4. Why? Because even if see, if there are one UPS, in one UPS there are different power module will be available. If any one power module is failed, no, that UPS have to sense this power module, and that load on that particular power module has to automatically transfer to the another power module of the same UPS. That is a complex design, no. So that's why I gave the score as complexity as 4. So third one is maintainability. I gave as 5 out of 5. Why? Because see, it is a completely, you can, if I want to touch this UPS, I can touch this UPS, until unless if you have to put the circuit breaker as 4 pole, here also 4 pole. If you are not putting the 4 pole, what will happen? The neutral will be common at input and output, and you cannot be you cannot take the maintain you cannot take the maintenance on this particular UPS. That's why how to make a circuit breaker as 4 pole, here also 4 pole. In such way, here also if you are putting 4 pole, you can also touch this UPS. Okay. So maintainability is nothing but if you want to touch this UPS, you have to open this breaker and open this breaker, and you have to do some PPM, whatever it is, you can do it. And the load on UPS can automatically transfer to the another system. So that's why the maintainability is more in this configuration, this parallel configuration. That's why I made as a score as 5. So next one is functionality. I gave the score as 4. Why? Because if any any low voltage, under voltage, anything will happen, what will in this configuration, it automatically goes to the battery mode, and power to your critical load will be a good, it is giving a good power quality to your critical load. So that's why I made as a functionality as I gave the score as 4. So next is redundancy level. In redundancy level, there is I gave the score as 5 out of 5. Why? Because see, UPS level redundancy also is there, and power model level redundancy also is there. Okay, if out of C, that is if assume that this is a 100 kVA. Okay, in 100 kVA means there will be a 25 power model, and there will be one static power model will be there. If any fault occur in this UPS and in this power model, and load on this UPS automatically transfers to the another 3. So that's why the power model redundancy also is there, and UPS level redundancy also is there. So that's why I gave the score as 5 in the redundancy level. So these are the criteria I gave the score for this parallel configuration. So and I have not give the such a score to the isolated run configuration. I will be putting some different video about this. Okay, so hope you will understand about parallel redundant UPS configuration. So if you are liking this, if you are like this video, please press the like button, and if you have any doubt, if you have any query, so please put your queries in the comment box. So I'm trying to address that your queries. So thank you for watching my channel, and keep supporting, and thank you. Bye bye.